हेलो एवरीवन, वेलकम टू क्वेश्चन सीरीज ऑफ सिंपल बेंडिंग इक्वेशन। सो मूविंग टू नेक्स्ट क्वेश्चन। हमारे सामने क्वेश्चन जहाँ पे आपके पास ये दे रखा है आपको सिंपली सपोर्टेड बीम, एंड बीम पे जो लोडिंग कंडीशन है आपको क्लियरली दे रखी है। उस पर लग रहा है आपका यूडीएल, एंड यूडीएल आपका है 200 किलोमीटर पर मीटर का, राइट। एंड यहाँ पे आपको क्रॉस सेक्शन दे रखा है जिसकी हाइट आपको दे रखी है 300 mm, एंड आपकी विड्थ दे रखी है 200 mm। एंड आपको यहाँ पे क्या निकालना है, आपको यहाँ पे निकालना है बेंडिंग मोमेंट एट पॉइंट सी विच इज़ 60 mm from top fiber and which is 1.2 meter from the left hand surface. I hope this question is clear. Now we will look into the R bending equation, that is sigma by y m by I E by R. And in this question it is not, E is not given and there is no talk about any R radius of curvature. So we will be looking at sigma by y and m by I. So let's calculate each term separately. If I calculate I, which is moment of inertia, that will be, so it is bending across this NA. So this will be 200 into 300 cube divided by 12, right? Now if I calculate y is calculated from the neutral axis, right? Y I have calculated from the neutral axis, and you have given 60 mm from the top fiber. If you see, its distance is 150 mm, and C from top surface is 60 mm. So from neutral axis its distance will be 90 mm. So y value is 90 mm, right? Now if I calculate m, from here, so if for calculating m, first I have to calculate the reaction. Let's suppose this support is A, let's suppose this support is B, correct? So it will be RA, it will be RB. If you look into this diagram, it's like a symmetrical loading, and if we can see that 200 Newton per meter is acting uniformly distributed load is acting on the distance of 4 meter, then total load is 800 kilonewton, and it will be acting at the midspan of this whole length, that is at 2 meter, and this is also 2 meter, correct? So from here it's not bending moment, we have to calculate shear stress at bending stress at point C, right? So bending moment at point C we can easily be calculated. So that is the first point, that is the second point. So bending moment at C can be calculated from this, like 800 newtons acting at the midspan, and as we can clearly see it's a symmetrical loading. So RA will be 400 kilonewton and RB will be 400 kilonewton. That load, the reaction load will be divided equally. Now if we want to calculate bending moment at point C, correct? So what we have to do, we have to consider this portion, right? And we will be calculating bending moment with LHS, correct? If we look into this, now let me clear some space, right? If I look into this, that RA was what RA is doing, RA is bringing it to a sagging moment, so the nature of RA will be positive. So RA, and it is acting at which distance? It is acting at a distance of 1.2 meter, so it is 1.2 meter. Now a UDL is also acting here, and what about UDL? So what about this UDL? So UDL is making this whole beam into a hogging, right? So the nature of this UDL will be negative. So what is the total load? Total load is acting 200 Newton per meter into 1.2 meter, right? So what is the total load? Total load will be 200 into 1.2, and it will be acting at the midspan, that is 0.6 meter. So the distance is 0.6. This is a load and distance will be 0.6, right? And I don't see any other load on the left hand side of this point C. Now calculate point C. RA is 400 into 1.2 minus 200 into 1.2 into 0.6. Now put this value in the calculator and just check what your answer is getting. Do along with me. 200 into 1.2 into 0.6. 400 into 1.2 minus this, it will be leading to 336 kilonewton meter. So answer of first part of this question is 336 kilonewton per meter is the bending moment at point C. Now we will be calculating sigma C. Right now we wish to calculate bending stress at point C. So here we have y, here we have I, here we have m. Just put all these value in this equation, you will be getting sigma. So it will be sigma C will be m by I into y of C. So y of C is 90 mm. So here putting all this value, bending moment at point C is 336 kilonewton per meter. Now value of I is 200 into 300 cube divided by 12, and value of YC will be 90, right? So after calculating this, 12 will be upper 336 into 10 की power 6 into 90 divided by 200 into 300 की power cube. Now after solving this, you will be getting sigma C, right? So this is the whole procedure. I hope this question is clear to you. Now we will be looking forward to other questions. Thanks.